Welcome, my friends, tonight. I invite you to close your eyes, slow your breathing, and journey with me to a place where time is patient, where movement is so slow it feels like the earth is simply holding its breath. We are going to the realm of glaciers, the great frozen rivers that flow not in seconds or minutes, but in centuries. Perhaps in learning their story, we may learn something about our own place in time. Some rivers flow with water, others take 1,000 years to move an inch. Yet both carve the earth, both feed life, both tell a story. The difference is only in the rhythm. Glaciers are those slow rivers, ancient, cold, and endlessly persistent. They are the memory keepers of the planet, but every memory has a beginning. So tonight, we begin with the first breath of ice. Imagine a snowflake landing gently on a mountainside. Alone, it is delicate, so light it could disappear with a single exhale. But here, in the high places of the world, where the air is thin and the cold lingers, it does not melt. It rests, it waits, and then another joins it, and another. Snowfall after snowfall, winter after winter, a quiet layering begins. At first, these are only soft blankets of white. But the weight builds. The snow beneath is pressed and packed by the weight above. Its crystals change shape, lose their airy openness, and begin to fuse. What was once a fragile lattice of ice becomes denser, tighter, and bluer, a new substance called firn. This is the first stage of a glacier's life, and it is not quick. It can take decades, sometimes centuries before enough snow piles up, compresses and transforms into the solid ice that will one day begin to flow. In this early stage, the snow is still in conversation with the sky. Every winter, the heavens exhale a fresh layer. Every summer, the warmth tries to take it back. And if the winters win more often than the summers, the glacier will grow. If the summers win, it will never be born. Glaciers are not made where the cold is constant alone. They are made where the balance between snowfall and melting tips toward accumulation. That is why we find them not only in the poles but also on mountaintops close to the equator. Think of the Andes, the Himalayas, Kilimanjaro. In their high altitudes, the air is too thin to hold much heat. Even under a tropical sun, the peaks can keep their white crowns. And in those crowns, tiny embryos of glaciers begin to form. A glacier is not a storm's creation, it is a patient sculptor of time, where rain carves in days, ice carves in ages. That first breath, the first snows that will never melt, must be followed by thousands upon thousands of breaths more. Under pressure, snow grains fuse, air is squeezed out, and ice crystals grow until they lock together into a single, massive body. This ice is no longer simply cold water. It is a mineral, solid and strong, with a density and hardness that allows it to grind rock beneath it. This slow metamorphosis is why glaciers are often called rivers of ice. But the truth is, in their earliest days they are more like sleeping rivers, storing energy and stillness, before they ever begin to move. When the weight becomes great enough, the glacier begins to deform under its own mass. Ice, though solid, can bend when given enough time and pressure. It flows not like liquid but like putty sliding over rock, creeping downhill. The first motion is imperceptible to the human eye. It might be only a few centimeters in an entire year. But over decades, centuries, the path becomes clear. The glacier has been born. These birthplaces are known as accumulation zones, the cold. High-altitude bowls where snow gathers, deepens, and compresses year after year. They are often cupped between mountain ridges, shaded from the sun, guarded by cliffs and peaks. In these hidden basins, the glacier takes shape, shielded from warm winds, and fed by storms that drift in from faraway seas. In polar regions, the accumulation zones can be vast plains where snow never melts, like Antarctica's east ice sheet. A place where some snow has lain undisturbed for millions of years. Here, the first breath of ice is so ancient, so untouched, that it predates the human species entirely. If you were there high in the mountains, or in the lonely white of the polar plateau, you would not hear much. Glaciers are not noisy when they are born. Perhaps the faint sigh of wind is the crunch of your own footsteps in snow that has fallen through centuries. But if you listened closely, if you stayed for days, weeks, months, you might hear the tiniest cracks, the settling of snow, the muffled shifting as layers settle more tightly together. This is the sound of transformation. There's something strange when you breathe in near a glacier. The air you take in may contain molecules that were last in the atmosphere thousands of years ago. As snow falls, it traps tiny pockets of air. These bubbles are sealed in as the snow compresses into ice. They remain there perfectly preserved until the ice melts or is drilled for study. Scientists can slice open a cylinder of glacier ice, melt it, and release that ancient air. It is literally a breath from the past, unchanged, unpolluted, carrying the chemical signature of an earlier Earth. In this way, the glacier's first breath is also the planet's memory. We rarely notice a glacier's birth. There's no single moment when it suddenly appears. No announcement from the mountains or the poles. It is a birth without an audience, except the sky, the land, and perhaps the stars. And yet from that quiet accumulation of snow, from the stillness of decades, something begins that will shape the face of continents, feed rivers, sustain life, and hold the stories of ages in its frozen heart.
Well, will where or what?
Into the birthplaces of giants, the cradles where glaciers begin their slow descent into the world. But for now, let us linger in this moment. The air is crisp. The snow beneath your feet is centuries old. And somewhere deep below, the first breath of ice has already begun to move. If the first breath of ice is the quiet awakening of a glacier, its life, then the place where that breath is taken is nothing less than a cradle for giants. These are the high, hidden places of the earth, places so remote and so still that they seem to exist outside of time. Far above the valleys where forests breathe and rivers run, there are lands that almost never feel the touch of summer. They lie in the shadows of towering peaks, where the air is so thin that every breath feels like a sip of glass-cold water. Here clouds sweep in, carrying gifts of snow. Storm after storm, winter after winter, the land receives layer upon layer, white upon white, year after year. These places the snow does not melt away in the summer. Instead, it gathers, compacts, and slowly transforms into ice. Over centuries, this ice becomes heavy enough to flow under its own weight. These are the birthplaces of glaciers, the accumulation zones that give life to the slow rivers of ice that will one day descend into the valleys below. A glacier's birthplace is called its accumulation zone. Here, snowfall is greater than snowmelt. This is the essential rule for a glacier's survival. If each year brings more snow than the summer sun can take away, then the glacier will grow. If the balance tips the other way, if summers win, the glacier will begin to die before it can even live. The size of an accumulation zone can range from a small mountain hollow, just a few hundred meters wide, to the vast expanse of Antarctica's interior, where the ice sheet stretches for millions of square kilometers. In the great mountain ranges of the world, glaciers are often born in cirques deep, bowl-shaped depressions carved into the rock by the ice itself in ancient times. These cirques cradle the snow, protecting it from warm winds and direct sunlight. Picture a great stone amphitheater, its walls rising like the ramparts of an ancient fortress, holding within them the beginnings of a frozen giant. Cirques often face away from the sun, toward the poles, north-facing in the northern hemisphere, south-facing in the southern hemisphere. This orientation helps them hold on to snow longer, delaying the summer melt. No glacier is born without the help of the sky. The atmosphere decides where storms will travel, where snow will fall, and where the cold will linger. Moisture from distant oceans is carried on the wind, lifted over mountain ranges, and released as snow when the air cools. This process, called orographic precipitation, is one of the main architects of glaciers. A single storm can lay down a meter of snow. Particularly harsh winter can bury the accumulation zone in layers so deep that the summer melt cannot hope to erase them. Over time, these layers become the foundation of a glacier's life. While mountain glaciers are dramatic, not all glaciers are born among peaks. In the polar regions, entire continents act as accumulation zones. Antarctica's east ice sheet, for example, is so vast that it holds enough frozen water to raise global sea levels by more than 50 meters. If it were to melt completely, here the snow falls light and dry, but the cold is so absolute that nothing melts. The accumulation is incredibly slow sometimes, just a few centimeters per year, but over millions of years, it builds an ice sheet several kilometers thick. In Greenland, the accumulation zone covers the center of the island, feeding massive outlet glaciers that creep toward the sea. Altitude is one of the most important factors in a glacier's birth. As you climb higher, the temperature drops roughly 6.5 degrees Celsius for every 1,000 meters in elevation. This means that even near the equator, a high enough mountain can host a glacier. Mount Kilimanjaro, for example, wears a shrinking but still present ice cap, despite being surrounded by tropical savannas. Latitude, of course, also plays a role. The closer you are to the poles, the lower the altitude needed for glaciers to form. In the Arctic, glaciers can grow right at sea level. Within every glacier lies an invisible boundary called the equilibrium line. Above it, in the accumulation zone, more snow falls than melts. Below it, in the ablation zone, more ice melts than falls. The position of this line determines whether a glacier grows, shrinks, or remains in balance. In colder years, the equilibrium line moves lower, allowing the glacier to advance. In warmer years, it climbs higher, forcing the glacier to retreat. The birthplaces of giants lie entirely above this line in the realm of endless snow. If you were to stand in the heart of an accumulation zone, you might hear almost nothing. No bird song, no rushing streams, only the faint hiss of snow carried by the wind. The world here is monochrome and hushed. Even the sun seems gentler, its light softened by reflection off endless white. And yet beneath this stillness, the first slow transformations are taking place. The snow is compacting, turning to fern, then to ice. Tiny crystals grow and interlock. Air bubbles are trapped, sealing away whispers from the past. Eventually, the ice in the accumulation zone becomes thick enough to deform and flow. Gravity takes over. The glacier begins its long journey downhill, funneled through valleys, spilling over cliffs and slow-motion ice falls, grinding rock beneath it into powder. The birthplace is left behind, but it never stops feeding the glacier. Year after year, it sends more ice downward, like a heartbeat pumping frozen lifeblood through a body of stone. Some accumulation zones have been feeding glaciers for hundreds of thousands of years, surviving entire cycles of warming and cooling. Others are far younger, born in the little ice age of the last few centuries. It's now already retreating in the face of modern warming. But in each one, the process is the same. Snowfall that never melts, patience that outlasts lifetimes, and the steady building of something far larger than itself. Now that we have seen where glaciers are born, we will follow them as they begin to move, as they become rivers that remember, carrying with them not just ice, but the stories of the world locked within. From the stillness of their high-altitude cradles, the giants begin to move. They do not rush. They do not announce themselves with the thunder of waterfalls or the roar of rapids. Instead, they slide forward in a silence so complete that it is easy to believe nothing is happening at all. But make no mistake, a glacier is a river of ice. And unlike any other river on Earth, it carries not just water but memory. We are accustomed to rivers rushing over stones, swirling around bends, bubbling and splashing as they go.
A glacier is none of that.
It flows without liquid, without sparkle, without sound, unless you count the distant groan of shifting ice or the muffled crack of a crevasse opening in its surface. This flow is the result of the glacier's own immense weight pressing down on itself. Ice, though solid, can bend and deform under pressure, especially over long periods of time. Given enough weight, the ice begins to act like a slow-moving fluid, creeping downhill, pulled by gravity. The pace of a glacier is almost beyond human patience. Many move only a few centimeters a day. At that speed, it would take more than a human lifetime for a glacier to travel from its birthplace in the mountains to the valley floor below. And yet there are exceptions. Some glaciers surge, suddenly accelerating to several meters a day for short periods, driven by changes in internal water pressure or the shifting of their base over bedrock. These surges remind us that even the slowest rivers can have moments of urgency. As glaciers move, they speak in a strange language, a language of cracks, groans, and deep booms. A crevasse is a glacier's most visible word, a great fracture that opens in the ice when it is stretched beyond its capacity to bend. Crevasses can be just a few centimeters wide, or wide enough to swallow a bus. If you stand near a glacier on a warm day, you might hear the occasional sharp crack as the ice adjusts, shifts, and settles. These sounds are like punctuation marks in the glacier's story. Perhaps the most extraordinary thing about a glacier's movement is what it carries with it. Year after year, snowfall compacts into layers of ice, each layer holding tiny air bubbles. Particles of dust, traces of pollen, and even fragments of volcanic ash from eruptions thousands of kilometers away. As the glacier flows, these layers move too, descending slowly toward the terminus, the glacier's end, or deeper into its interior, where they may remain locked away for centuries. If a scientist drills into the glacier and extracts an ice core, they can read these layers like pages in a book. The size and shape of the air bubbles reveal past temperatures. The dust tells of dry periods when winds carried particles from far-off deserts. Traces of certain gases reveal the state of Earth's atmosphere centuries, even hundreds of thousands of years ago. In this way, glaciers become archives of climate history. The Greenland ice sheet contains records going back more than 100,000 years. The Antarctic ice sheet holds memories stretching back over 800,000 years. These are not vague stories or legends. They are precise, physical records, direct samples of ancient air, frozen in place and untouched until the moment they are released. The glacier remembers the volcanic winter after the eruption of Mount Tambora in 1815. When the sky darkened and snow fell in midsummer, it remembers the Industrial Revolution's first emissions of coal smoke and soot. It remembers even older events, the last ice age's bitter cold, the slow warming that followed, and the rise of human civilizations along newly exposed coastlines. A glacier's movement is not a straight descent, like a river flowing over a slope. It is shaped by the land beneath, by valleys, ridges, cliffs, and plains. It bends around obstacles, squeezes through narrow gaps, and spills over steep drops as ice falls, cascades of shattered ice blocks that resemble frozen waterfalls. Beneath the glacier, meltwater may form thin films or channels, lubricating its base and allowing it to slide more easily over bedrock. This meltwater is not warm in the way we think of warmth that exists at the exact melting point, born from the immense pressure and friction at the glacier's base. As it moves, a glacier is not gentle. It scrapes and scours the rock beneath it, carrying with it a cargo of stones, gravel, and fine powder called glacial flour. Over time, this grinding action deepens valleys, carves U-shaped troughs, polishes bedrock into smooth, striated surfaces. The sediment it carries will be dropped far from where it began, sometimes hundreds of kilometers away, reshaping landscapes entirely. This is how glaciers leave their mark, not just as rivers of memory, but as sculptors of the very Earth itself. Eventually, the glacier reaches lower altitudes, where temperatures are warmer. Here, in its ablation zone, melting outpaces snowfall. The glacier's surface darkens with dust and debris, absorbing more sunlight and hastening the melt.
Streams of icy water carve channels into the glacier's surface,
Plunging into deep shafts called melons before re-emerging at the glacier's snout. From here, the water joins liquid rivers, continuing its journey to lakes, seas, and oceans. The ice that began as a snowflake in the accumulation zone may now quench the thirst of forests, fields, and cities far below. Even as it melts, a glacier is still telling its story. The sediment left behind moraines, drumlins, eskers are the punctuation marks at the end of its chapter. When the ice is gone, the land remembers where it was. The shape of the valley, the stones in its floor, the lakes in its hollows, all are the glacier's handwriting on the earth. In the next part of our journey, we'll see how these rivers of memory become architects of the earth, shaping entire landscapes, carving valleys, and leaving behind forms that will outlast the ice itself. Beneath the slow silence of the high mountains, and under the pale light that glints off ancient ice, there is a force at work, so patient, so deliberate, we can barely comprehend its scale. It is not the violent rush of rivers or the sudden collapse of cliffs. It is not the burst of volcanic fire or the convulsions of earthquakes. This is a force that measures time not in seasons but in millennia. It is the glacier, a frozen architect that sculpts the bones of the world. From a distance, a glacier might seem inert, almost lifeless, a vast white stillness draped over stone. But this stillness is deceptive. Inside, every crystal of ice is in motion, pressed by its own immense weight, sliding ever so slowly under the pull of gravity. The ice deforms and flows, as if it were a river slowed down 1,000-fold, creeping toward the valleys and plains far below. It is in this motion that the glacier becomes a maker. Like a master sculptor with a chisel, it carves, shapes, and reshapes the land. Each jagged peak, each U-shaped valley, each sweeping ford that we admire today is a signature, etched patiently into the earth over countless ages. The glacier works in two ways. First, it plucks. As it moves, the ice grips the fractured edges of the bedrock, prying pieces loose. These stones, some small as pebbles, others massive as houses, are carried away, embedded in the glacier's body like tools in the hand of a craftsman. Second, it grinds. Beneath the glacier, those stones are pressed against the ground with a weight measured in millions of tons. They scrape, crush, and pulverize the rock beneath, turning it into fine powder glacial flour that will one day drift in rivers and oceans, tinting the water with a milky hue. To stand in a valley carved by ice is to witness this work. The walls are steep and sheer, the floor broad and flat, the shape unmistakably different from the V-shaped valleys carved by rivers. Nature's handwriting is clear here, and it spells the slow patience of frozen time. Long before human eyes saw them, mountain ranges looked different. Their peaks were sharper, their slopes wilder, their ridges unmarked by the flowing ice. Then the glaciers came, and with them, a great reshaping began. Cirque's bowl-shaped amphitheaters formed high on the slopes, scooped out by the turning of ice against stone. Ridges called arêtes grew razor-thin as ice eroded both sides, leaving a knife's edge of rock between two valleys. And where several glaciers converged, they left behind towering horns, isolated peaks like the Matterhorn in Switzerland, standing as monuments to ice's persistence. What volcanoes build in years, and what rivers carve in centuries, glaciers can transform in tens of thousands of years, altering entire mountain systems. And when they retreat, they leave behind landscapes almost unrecognizable from what stood before. The glacier's work is not confined to the mountains. As it travels, it carries with it a cargo of stone, gravel, and sediment, the raw material of new landscapes. When the ice melts, it deposits this load in broad, rolling hills called moraines, in long ridges called eskers, and in vast outwash plains where meltwater fans across the land. These deposits become the fertile soils of valleys and prairies. They feed forests, grasslands, and eventually human civilizations. Much of the rich farmland of northern Europe, the American Midwest, and the plains of Canada exists because of glaciers' long-ago journeys. Without them, the breadbaskets of the world might never have formed. We often think of architecture as a human endeavor, the grand designs of cathedrals, bridges, and cities. But glaciers have been drawing blueprints for millions of years, reshaping continents long before the first stone walls rose. They are not bound by the urgency of human lifetimes. Their work spans ice ages and warm periods, advancing and retreating in great cycles. In each advance, they erase and redraw the map of the land. In each retreat, they reveal the latest edition of their design. To understand a glacier's architecture is to understand that the Earth is not static, but alive not in the biological sense, but in the way it is continuously formed, destroyed, and reborn. When the last ice retreats from a region, it leaves behind more than just altered landforms. It leaves a memory not written in books, but in the terrain itself. A valley tells the story of the glacier that carved it. A boulder, sitting improbably in the middle of a plain, tells of the ice that carried it from a mountain far away. A chain of lakes, sparkling in the sunlight, marks the depressions left by melting blocks of ice. We walk through these landscapes every day, rarely thinking about the forces that shaped them. Yet every step we take on flat farmland, every view we admire of a mountain lake, is possible because of these ancient architects. In this way, glaciers are historians and artists at once. They keep perfect records, yet they also erase and rewrite the land's surface. To watch them is to watch the patient work of both memory and change. The human mind struggles to truly grasp their scale, We measure time in minutes, in seasons, in a few decades, if we're lucky, but a glacier measures time in millennia. It doesn't care for the rush of our days. It advances or retreats with the steady, unhurried breath of the planet itself. And yet, like all timekeepers, glaciers are not eternal. Our clocks can be wound down. As the world warms, these great recorders of the past begin to melt, releasing their stories in torrents of cold water. The pages of the ice book drip away, unread. The ticking grows faster, then stops. The oldest clocks in the world are falling silent before we fully learn their language. Standing beside one, you may feel small, but also connected, as though your life is just one more snowflake settling on its surface. One more moment in the vast calendar of the earth. You cannot stop the ticking, but you can listen. And in that listening, perhaps you will hear not just the history of ice, but the history of yourself. Because the truth is, we are all made of time. And glaciers, they are the keepers of it. In the farthest corners of our planet, where sunlight bends low across the horizon and shadows stretch for hours, life slows to a pace so deliberate it seems like time itself has thickened. Here the landscape glitters not because of wealth, but because every molecule of water has been captured in a crystalline stillness. The air is sharp, the silence is complete, and the wind carries stories from centuries past, frozen in place, waiting for the rare thaw that might let them speak again. The frozen ecosystems of our planet are not simply empty deserts of ice. They are archives, laboratories, mirrors, and guardians, each snowflake a page in a diary written across millennia. They regulate the heartbeat of the climate, protect oceans from overheating, and act as great reflectors, bouncing sunlight back into space. In a warming world, they are also the most fragile. The polar ice caps are more than vast surfaces of white. They are the cooling engines of Earth. Snow and ice possess a property called albedo, the ability to reflect incoming sunlight back into space. Fresh snow can reflect up to 90% of sunlight, acting as a planetary mirror. Without these mirrors, the planet would absorb more heat, tilting the balance of climate toward dangerous extremes. In Antarctica, the ice sheet is so thick in places that if you stood atop it, you would be looking down through 4 kilometers of ice before reaching bedrock. Locked within those layers are bubbles of ancient atmosphere, tiny time capsules containing the chemical breath of the Earth from hundreds of thousands of years ago. Scientists drill deep ice cores, extracting slender cylinders that reveal histories of volcanic eruptions, shifts in greenhouse gases, and ancient storms. Every layer is a frozen memory, precise and unaltered. The Arctic, in contrast, is an ocean wrapped in seasonal ice, alive with movement and transformation. The sea ice grows each winter, retreating each summer, its rhythm as old as the planet's modern climate. This seasonal heartbeat determines ocean currents, weather patterns, and even the migrations of animals thousands of kilometers away. We tend to think of ice as lifeless, a frozen grave. But beneath the white surface, life thrives in hidden ways. In the upper layers of Arctic sea ice, microscopic algae grow in thin brine channels, feeding tiny crustaceans that in turn feed fish, seals, and polar bears. In subglacial lakes buried under kilometers of Antarctic ice, scientists have found microbial communities that have survived in complete darkness for hundreds of thousands of years, feeding on minerals dissolved in the water. These ecosystems exist without sunlight, reminding us that life can find a foothold even in the most hostile corners of the planet, perhaps even on frozen moons like Europa and Enceladus. Frozen tundra regions, known as permafrost, hold more carbon than all the forests of the world combined. This frozen soil has locked away plant matter for tens of thousands of years, preserving it like nature's deep freezer. But when permafrost thaws, microbes awaken and begin breaking down the material, releasing carbon dioxide and methane into the atmosphere, gases that can accelerate global warming. In this way, frozen ecosystems are both climate stabilizers and potential climate amplifiers. Every snowflake that falls in Antarctica is part of a conversation between sky and sea, between weather and geology. Over centuries, snow compresses into ice, trapping bubbles of air that hold messages from eras long past. In 2010, scientists extracted an ice core from Dome Sea in East Antarctica. revealing atmospheric records stretching back 800,000 years. The gases inside told a story of natural climate rhythms, ice ages, and warm periods until, suddenly, in the most recent layers, the chemical signature shifted. Carbon dioxide levels spiked sharply, unlike anything in the previous 8 cycles of glacial and interglacial phases. The ice bore witness to the Anthropocene before we had even named it. It isn't only gases. Dust layers and ice reveal ancient droughts in Africa, volcanic ash records, catastrophic eruptions, and isotopes from cosmic rays mark times when solar activity shifted. Frozen ecosystems are historians with perfect memory. When frozen ecosystems melt, their disappearance is not loud. Ice doesn't cry out when it vanishes, but its absence changes everything. The loss of Arctic sea ice accelerates warming in a feedback loop. Less ice means less reflection of sunlight, which means more heat absorbed by dark ocean water, which melts even more ice. Greenland's glaciers are pouring billions of tons of fresh water into the ocean each year, slowing down the great conveyor belt of currents that distributes heat around the planet. Permafrost thaw is awakening ancient bacteria and viruses, some harmless, some not, on 2016. An anthrax outbreak in Siberia was linked to the thawing of a decades-old reindeer carcass buried in permafrost. What else lies buried, waiting for a warmer day? Ice is a paradox. It is both movement and stillness, fragility and endurance. It can shatter under a human step, yet hold the memory of a million years. To stand in a frozen ecosystem is to feel the weight of time pressing in from all sides. The Sami people of northern Scandinavia speak of Gavi, a deep, quiet snow that muffles every sound, where the world feels paused. In Inuit tradition, the sea ice is not simply a surface, but a living partner in survival, an entity to be respected, read like a map, and listened to like a friend. Philosophers might say, ice is the purest expression of impermanence, a state that demands patience, yet promises change. The frozen world teaches us that what looks unchanging is always in motion, and what seems eternal may vanish in a single warm season. If frozen ecosystems vanish, the planet's future changes in ways we cannot fully predict. We lose not just ice, but the stability it provides, the history it preserves, and the life it shelters. Protecting these frozen realms is not about saving a distant wilderness. It is about safeguarding the operating system of the planet. Efforts to preserve them from limiting greenhouse gas emissions to designing marine protected areas in the Arctic are not acts of charity toward nature. They are acts of self-preservation. For when the ice goes, we go with it, into a warmer, less stable, and more unpredictable world. Each winter, snow still falls. Glaciers still groan as they slowly slide to the sea. Beneath the ice, ancient microbes still dream in darkness. The frozen ecosystems are not gone yet, beneath the thin skin of our planet's atmosphere. Ice has always been more than frozen water. It is memory solidified. A chronicle etched in crystalline layers, each snowfall a page, each trapped bubble of air a whisper from an ancient sky. For millennia, these frozen archives have sat quietly on mountain peaks, in polar deserts, on shaded glaciers, and deep below the Arctic permafrost, preserving the story of Earth long before we could read it. But now the pages are dissolving, and the story is changing faster than our eyes can follow. The cryosphere, the collective frozen realm of ice sheets, sea ice, glaciers, permafrost, and snow cover, has been our planet's great stabilizer. It reflects sunlight back into space, keeping the global thermostat in check. It holds rivers in waiting, releasing them in spring so life can flourish. It anchors coastlines by holding sea levels steady. Yet in the last century, the cryosphere has shifted from guardian to witness, from stable to restless. Satellite images show the Arctic Ocean in September shrinking year after year, its summer sea ice retreating into ghostly fragments. Greenland's ice sheet thick enough to bury the Eiffel Tower. Nearly 3,000 times the shedding mass at an accelerating pace. Antarctica, once thought immune to quick change, is bleeding glaciers into the Southern Ocean. This is not the slow heartbeat of geologic time. This is the rush of meltwater into a warming sea. Glaciers are rivers of ice, inching forward under their own immense weight, sculpting valleys and mountains as they go. For thousands of years, their movement has been measured in centimeters a day. Now, many are sliding faster, some up to 10 times their historical speed, lubricated by meltwater pooling at their base. In the Himalayas, the third pole of the Earth, glacier melt feeds rivers that support nearly 2 billion people. When the glaciers vanish, those rivers will still flow for a while, fed by seasonal rains, but their rhythm will falter. In the Andes, ice that took centuries to accumulate disappears in a single hot summer, leaving mountain villages without their only dependable source of water. Glacier melt is no longer a local loss. It is a global event. The oceans, vast and patient, have always been slow to change. But as the cryosphere melts, they swell with water from land ice and expand under the heat they absorb. It is a double strike: thermal expansion and meltwater influx. Coastal cities like Jakarta, Miami, and Dhaka now face a creeping reality, not sudden floods, but tides that climb a little higher each year, storm surges that bite a little deeper into neighborhoods. Islands in the Pacific are losing ground quite literally, as saltwater swallows beaches, seeps into groundwater, and pushes communities inland, often with nowhere left to go. By the end of this century, sea levels may rise by 1 meter or more, if the Antarctic ice shelves collapse entirely. And 1 meter is enough to redraw the map. While ice melts on the surface, another thaw is happening underground. Permafrost, the permanently frozen ground of the Arctic and subarctic, stores more than twice the amount of carbon currently in our atmosphere. As it thaws, microbes awaken, feeding on ancient plant matter and releasing carbon dioxide and methane into the air. It is a feedback loop with teeth. Warming melts permafrost, which releases greenhouse gases, which accelerates warming. And unlike human-made emissions, we cannot simply turn off permafrost thaw. In Siberia, sinkholes have appeared where the ground collapsed into itself. In Alaska, roads buckle and homes tilt as their frozen foundations soften. And from the thawing soil, the past returns bacteria, viruses, and even the remains of mammoths, preserved for tens of thousands of years, suddenly exposed to the modern world. White ice is a mirror. Dark ocean water is an absorber. As the ice retreats, it exposes darker surfaces, which absorb more heat, which melts more ice. And this albedo feedback is one of the fastest accelerators of climate change, and it is already well underway in the Arctic. Scientists have tracked a sharp drop in the region's reflectivity over the last few decades. Where summer sea ice once reflected sunlight like a shield, open water now drinks in heat, raising regional temperatures at more than twice the global average. This Arctic amplification isn't confined to the poles. It ripples through global weather patterns, altering jet streams, monsoons, and storm tracks. We often talk about melting ice as though it belongs to some faraway place, but its effects reach directly into human lives. Changing snowpack disrupts agriculture. Shifting seasons confuse pollinators. Meltwater pulses change the chemistry of oceans, altering where fish and thus fisheries can survive. In the far north, indigenous communities face a cultural loss as well as a physical one. Hunting routes, ancestral burial grounds, and sacred sites vanish under the melt, taking with them traditions passed down over generations. And yet there is resilience. Coastal defenses are being redesigned. Communities are moving to higher ground. Renewable energy is scaling faster than ever before. But the question remains, will action outpace the thaw? We are living in the hinge moment between two Earths. One with ice as we have always known it, steady, dependable, shaping climate for millennia. One with less ice, warmer seas, and coastlines redrawn. The melting future is not inevitable, but it is unfolding. Every fraction of a degree we prevent matters. Every glacier saved buys time. Every community protected keeps the story of ice alive a little longer, because ice does not simply vanish. When it melts, it moves into the sea, into the air, into our weather, and into the deep narrative of what the Earth will become. The frozen archives are opening, and the story they are telling is one we will live through, page by page, drop by drop. Water remembers. At least, that is what the poets have whispered for centuries, what shamans have sung beside flickering fires, and what the oceans themselves seem to murmur when the tide retreats. Treat it as a resource, as something to drink, to wash with, to navigate across. But water is far older than we are. Its molecules carry stories far beyond human history, and in its silent currents lies a memory older than the Earth itself. The water in your glass right now is ancient. It may have passed through the roots of a primordial fern 400 million years ago, hidden deep beneath the forest floor. It may have been locked in Antarctic ice for 30,000 years, cradling microscopic air bubbles from a forgotten age. It may have fallen as rain on the scales of a dinosaur, or boiled away from a comet that wandered too close to the sun before finding its way here. Every molecule of Acho is a survivor of cosmic and terrestrial journey syndrectriclic in essence, endlessly reshaped in form. But what does it mean for water to have memory? In science, memory is not a mystical imprint, but a record of events encoded in matter itself. Ice cores drilled from Greenland's depths hold annual rings of frozen history, each layer trapping tiny pockets of air, volcanic ash, and chemical fingerprints of ancient climates. These frozen archives speak of shifting winds, great extinctions, and warmings and coolings long before human eyes could witness them. Glaciers, rivers, and ocean sediments are libraries, and their pages are liquid, crystalline, or muddy, but each one is written in water's language. And water's memory is more than chemical. It is also geographical. When rain falls on a mountain, it carries the isotopic signature of its origin ratios of oxygenate and deuterium that reveal the temperature, altitude, and distance the vapor traveled before condensing. Scientists can read these isotopes like a map, tracing the journey of a drop from equator to pole, from cloud to aquifer. Every raindrop is a traveler with a passport stamped by winds, clouds, and sunlight. Yet perhaps the most mysterious part of water's memory is how it shapes living memory. Human brains are, in essence, water-laden archives. About 73% of our brain mass is liquid, and without it, electrical impulses would falter, thoughts would stutter, and memory itself would dissolve. The very capacity to recall our pasto dream, to imagine, to weave stories, bound to water's role in our cells. The rivers outside and the rivers inside mirror each other. Both carry signals, nutrients, and a record of change. Water also remembers through shape. Look at the winding course of a river from above. It meanders like a script, recording centuries of erosion and flood. Each curve is a sentence, each oxbow lake a forgotten paragraph. Ocean currents, too, write sprawling novels across the globe, transporting heat and salt in patterns that influence weather, migration, and even human history. The Gulf Stream, for example, is not just a current, it is a chapter in Europe's climate stability, a conveyor belt that has kept winters mild for millennia. And when ice melts, it releases its oldest pages into circulation. A thawing glacier breathes out air last touched by Pleistocene winds, its waters mingling with rivers, lakes, and seas, altering the chemistry of modern oceans. In that mingling, old and new blend, a merging of past and present that will influence the future. In myth, water's memory has always been revered. In ancient Greece, two rivers flowed through the underworld. Lethe, whose waters erased memory, and Mnemosyne, whose waters restored it. Drink from one, and you forget your earthly life. Drink from the other, and you recall all you have ever been. The choice for the dead was whether to dissolve into oblivion or carry knowledge into eternity. Even in science, we are beginning to understand that the forgetting and remembering in nature as waters is real thaw, not in the mystical sense. Patterns dissolve and reform, data is lost or altered, but traces always remain somewhere in the cycle. Perhaps this is why water moves us so deeply. We sit beside waves, listen to rain, or watch a river's endless journey, and we feel something ancient stir in USA recognition that we, too, are part of the same unbroken cycle. The tears we shed in grief or joy join an ocean that has seen every sorrow and celebration before. The water in them will someday rise into the clouds, fall as snow, or return to the sea, carrying our moment with it, quietly adding to the memory of the world. And so, the memory of water is not just about what it has witnessed, it is about what it will carry forward. The floods, the droughts, the melting ice sheets, the poisoned river cell, these will be written in water's record, passed on. To the future in the flow of oceans, in the mist of storms, in the frozen vaults of polar ice, water remembers. And in remembering, it teaches us that nothing is ever truly lost, transformed, carried onward in an endless story. In the farthest reaches of the world, where the wind carries the sound of nothingness, and the sun skims the horizon without ever climbing high, ice reigns as both a king and a prophet. Here, it is not just frozen water, it is memory, it is language, it is a living archive written in a script older than the oldest human tongue. And in this endless white expanse, myths are born not in the way of books or scrolls, but in the shifting glow of auroras, in the haunting creak of glaciers, and in the whispers of frost carried through centuries. For as long as humans have wandered the earth, we have looked at ice and seen more than a substance. We have seen stories. In the flickering patterns of frost on winter windows, in the frozen stillness of mountain lakes, in the white deserts of the poles, we have always found shapes and meanings. Ice, in our myths, is both the beginning and the end, the womb of creation and the shroud of apocalypse. Long before satellites mapped the poles, before explorers carved their paths through the Arctic winds, the far north and south were realms of imagination. To the ancient Greeks, the north was home to Hyperborea, a land beyond the north wind, where people lived in eternal spring under a golden light. The ice to them was not the end of life, but the boundary of paradise. In contrast, Norse myths spoke of Niflheim, a realm of ice and mist, where frost giants slept and waited for the day they would walk the earth again. In these legends, ice was not paradise. It was the raw, untamed chaos from which the world was forged. And then there is the South, a place unseen by ancient eyes but deeply imagined. Medieval mapmakers etched Terra Australis Incognita into their scrolls, a mythical southern land that balanced the earth like a counterweight. They believed it must be there because symmetry was too elegant a law for nature to ignore. That imagined land would later become the Antarctica we know, but for centuries, it was a land of pure legend. Some myths, ice is not a place but a prison. The Greek titan Kronos, overthrown by his son Zeus, was said by later storytellers to be bound in chains in the farthest, coldest reaches of the world. In Inuit legends, spirits of hunger and storms are locked away in glaciers, only to be freed when humans grow careless or disrespectful toward the land. Even in modern times, the idea persists that something ancient sleeps in the ice. Stories of frozen mammoths, perfectly preserved in Siberian permafrost, blur the line between science and legend.
Ow.
We know they are real, yet the sight of them feels mythic, as though the past itself has been caught mid-breath, waiting for the warmth of our touch to awaken it. In recent decades, as climate change melts glaciers, this mythic idea has gained a strange new life. Bacteria, viruses, seeds, things untouched for tens of thousands of years have re-emerged from melting permafrost. Science tells us they are real biological entities. Myth tells us they are spirits, long imprisoned, returning to a changed and unready world. Many cultures see ice as more than just part of the earth. They see it as part of the architecture of the cosmos. In some Siberian myths, the Arctic ice cap is the nail that holds the sky in place. Without it, the heavens would collapse onto the earth. This is not so far from the truth, for the polar ice reflects sunlight back into space. Keeping the planet's balance, melt it entirely, and the balance shifts. The myth becomes a prophecy. Similarly, in Maori tradition, the Great Southern Ice was said to be a sacred place, the realm of Te Waka Mdui, the canoe of the demigod Mdui. It was not meant for humans to disturb. To venture there was to risk upsetting the world's harmony. Now, as ice sheets fracture and glaciers calve into the ocean, the old warning feels like a whisper through time, a reminder that the balance we break will eventually break us. The idea that ice could end the world is one of humanity's oldest fears. In Norse prophecy, Ragnarok, the end of the world, begins with Fimbulwinter, a season of unending snow and ice. The sun will hide, the earth will freeze, and the gods themselves will fall. Science, too, speaks of ice ages that reshape the world, freezing vast continents and forcing life into narrow refuges. There was even a time, hundreds of millions of years ago, when Earth may have been entirely encased in ice, a snowball Earth. For creatures that lived then, it must have felt like the end. Yet from that frozen silence, life found a way forward. Myths remember the fear. Geology remembers the survival. It is tempting to think of myths as relics, old tales from a less scientific age. But the myths of ice feel eerily present. They speak of balance, of imprisonment and release, of endings that come with snow. They teach that ice is never truly still. It waits. It listens. It remembers. As the glaciers melt and polar seas open, we find ourselves living in a strange inversion of the old stories. Once ice was imagined as the threat, the force that could end the world. Now it is the loss of ice that haunts us. We fear not the advance of glaciers, but their retreat. And so the myths turn inside out. The sleeping beasts in the ice are not giants with hammers or gods in chains. They are the ancient waters themselves, held in solid form for millennia, now slipping free and rushing to the sea. The nail that held the sky is loosening, and the balance of the world shifts. If the myths of ice have taught us anything, it is this. Ice is a storyteller. It records in layers, each snowfall a page, each trapped bubble of air a word. Within the Greenland and Antarctic ice sheets are stories going back hundreds of thousands of years, written in isotopes, dust, and ash. These are not myths, they are histories. Yet the longer we leave them, the more they begin to feel like both truths that read like legends. One day, the last great ice sheets will melt. When that happens, the library will vanish. The myths will remain, but the original pages, the ancient words of the earth, will be gone. And perhaps in the far future, someone will tell a story about the time when the world was capped in white, when the poles gleamed like mirrors to the sun, and when humans lived under skies held up by ice. They will speak of how it melted and how it changed the earth forever. And they will tell it not as science, not as history, but as a myth, the last great myth in ice. There will be a morning, somewhere far ahead in time, when the first light spills across the horizon and does not find the ice. The glaciers will have already retreated beyond memory, their last fragments dissolved into the veins of the ocean. The frozen rivers that once stitched mountaintops to valleys will be gone, and the seas, unbound, will lap at unfamiliar shores. For thousands of years, the earth has breathed through ice, inhaling in the slow winters of the Pleistocene, exhaling in warmer interludes like ours. The white skin of the poles has been the planet's great mirror, a shield of light that reflected the sun's gaze back into space. Without it, the Earth's face will darken, absorbing heat instead of deflecting it, and the slow fever will rise. When the ice is gone, sea levels will not simply climb, they will migrate, redrawing the map of the human world. Cities that once bustled on coasts will be remembered in drowned ruins beneath silt and seaweed. The names of ports Alexandria, Mumbai, Miami, Shanghai may become entries in the next generation's archaeology textbooks. The water will not come in a single wave, but in a patient, unstoppable creep. It's a kind of change that's invisible until it has already remade the shape of the land. But the loss is not only geographic. Ice is time made visible. Every layer in a glacier holds a chapter of the atmosphere of ancient storms. Volcanic ash, the breath of forests long turned to soil. When the last ice melts, those archives will pour into the sea, their records erased in brine. We will lose not just cold, but memory. The animals will notice first. Polar bears will vanish before the final meltwater rivers disappear, their hunts cut short by the breaking of their hunting grounds. Seals will lose their nurseries. Penguins, born into a clockwork of seasonal freeze and thaw, will face a calendar with missing pages. The migrations of whales, the deep ocean giants who have followed ice edges for generations, will falter as the edges themselves vanish. The oceans will swell not only with melted ice but with heat. Warm water expands, and the thermal bloating of the seas will add to their reach. Currents will shift, redrawing the invisible highways that carry nutrients and life. Coral reefs, already weakened, will bleach into bone-white cemeteries. The Arctic Ocean, once capped with silence, will become a navigable sea, and with it, human industry will spill into places that have never known it. Extracting, drilling, dredging. There will be a cultural shift, too, in the absence of ice. For millennia, it has been a symbol of purity, resilience, and eternity. Myths told of gods who dwelt in frozen palaces, of demons entombed in glaciers, of the first humans shaped from snow. Future generations will hear these as fairy tales without landscapes to anchor them. The metaphor of ice will no longer carry the same weight when no one has seen it outside of a screen or a museum's climate-controlled vault. And yet, life will not end. It will change. The Earth has reinvented herself many times before. The lush forests of the Carboniferous, the sun-baked deserts of the Triassic, the ice-wreathed silence of the last glacial maximum, all were chapters in a restless story. When the ice is gone, new ecosystems will emerge in the wake of the old. Grasses will colonize tundra. Birds will find nesting grounds on the new coastlines. Humans will adapt. They always have, though adaptation will not be evenly shared. Some will see opportunity in the open Arctic sea routes in the farmland revealed by thawed permafrost. Others will face displacement, famine, and the loss of homelands. The great migrations of the next century may not be of wildebeest or caribou, but of people, moving inland, uphill, away from the swallowing seas. The question that will remain is whether we will remember the ice as something we tried to save, or as something we simply watched vanish. Perhaps the most haunting thought is this: when the ice is gone, the Earth will keep spinning. The sun will keep rising. The tides will keep coming in and going out. There will be no single moment when the planet announces its loss. The absence will be quiet, and that quiet will be the loudest thing of all. The far future, if ice ever returns, will be because the world has entered another deep freeze, not in the lifespan of any civilization we know. Until then, the memory of it will live in stories, in the fossils of creatures adapted to a world of white, and in the sediments of the deep ocean, where traces of its melt will settle. We will tell our children about the taste of snow, the sharp smell of air over a frozen lake, the way light fractured in a cave of blue ice. And they will imagine it the way we imagine the primeval forests and the ancient seas, vast, unreachable, half-myth. Because when the ice is gone, it will be not only a physical loss, but the erasure of a chapter of human experience. And in that silence, the question will linger, echoing across the warm, iceless seas. What did we trade it for? Thank you for sharing this quiet journey with me. If tonight's wander through ice and time helped you breathe a little slower and see the Earth a little clearer, stay close. Gently tap, subscribe, and like, and let the bell rest beside you, so it can wake only when the next midnight story arrives. Till then, close your eyes, soften your shoulders, and let the world turn without you for a while. Good night from the Sleep Scientist.